Hi, this is Alex from devstories.eu. OpenCV Computer Vision Deep Dive, Episode 14 of 20. While humans think of color as a mixture of red, green, and blue, trying to program a computer to track an object using RGB is a nightmare the moment a cloud covers the sun. The solution lies in how we mathematically represent and combine pixels. Today, we are looking at pixel alchemy, alpha blending, and color spaces. The core problem with the RGB color space is that it couples color information directly with luminance. If a shadow falls across a bright green object, its red, green, and blue pixel values all shift significantly. To a standard thresholding algorithm, a shaded green object looks entirely different from an illuminated one. To fix this, you transform the image from RGB to the HSV color space. HSV stands for hue, saturation, and value. Hue represents the base color itself as an angle on a color cylinder. Saturation represents the intensity of that color, and value represents the brightness. By isolating the pure color information into that single hue channel, your computer vision pipeline becomes highly resistant to lighting changes. You can configure your logic to look for a specific shade of green, and it will find it whether the room is brightly lit or dim. This robustness is critical when building something like an automated green screen system for a broadcast. You want to seamlessly blend a dynamic weather map behind a news anchor. First, you take the camera feed and convert it to HSV. You then define a range of green hues corresponding to the physical backdrop. For every pixel that falls inside that green hue range, you output a 0. For everything else, like the anchor, you output a 1. This creates a binary mask. This mask acts as your alpha channel. Here's the key insight. Listeners often talk about alpha as if it were a color, almost like a transparent dye. It is not. Alpha is purely a numerical weight, a scalar value between 0 and 1 that dictates opacity in a linear interpolation equation. Image blending is simply pixel by pixel arithmetic. To combine the foreground anchor and the background weather map, you use a specific equation. For every pixel, the final output color equals the foreground pixel multiplied by the alpha value plus the background pixel multiplied by 1 minus the alpha value. Think through the math of that green screen scenario. Where the anchor stands, alpha is 1. The foreground pixel is multiplied by 1, preserving the anchor perfectly. The background weather map pixel is multiplied by 1 minus 1, which is 0. The weather map disappears in that exact spot. Conversely, where the green screen sits, alpha is 0. The foreground green pixel multiplies by 0, erasing the physical screen completely. The background weather map pixel multiplies by 1 minus 0, which is 1, making the weather map fully visible. If you want a smooth anti-aliased edge around the anchor, you use fractional alpha values like 0.5 along the boundary. This averages the foreground and background pixels together to avoid harsh, jagged outlines. The single most useful thing to remember is that images in memory are just matrices, and pixel manipulation is just matrix arithmetic. Choosing the right coordinate system, like HSV, makes that arithmetic robust and predictable instead of fragile. Thanks for spending a few minutes with me. Until next time, take it easy.